So today we are covering database connections, big exam times. Database connection. So, or really more like this is the different ways that we save the data that will go into databases or save the data that we fetch from databases, how we work with databases inside an actual application. Big burger. Wow, geez, I've really lost touch with the kids. I have no idea what you guys are talking about now. So I'm kidding. I'm actually not that much older than you, I guess. Anyway, so we're going to go in a slightly different order. This section officially starts on page 164 in your book, but I think the order that they go is a little bit weird. I'm not even going to encourage these chat messages because I have no idea what I'm saying. Okay, so we're going to start with XML instead because it's just a very obvious place to start because it's super easy. So yeah, you guys have seen XML before. Do you guys remember where you have seen it before? What section was it? What context? In what context were we discussing XML? Web services. Wow. Yeah, precisely. So yeah, that is where you've seen it before because it's how the sort of messages are passed between a client accessing a web service and the server running the web service. But yeah, essentially more broadly than that, XML is a text-based way to represent structured data. Okay, that's just how they define it. You can also just see it as a markup language. So it's a language designed to be read by both humans and machines. But yeah, the official purpose of XML is to say it's a text-based way to represent. Yeah, Adam, Alex, both of you are right. It is usually used in that context. In fact, markup languages generally are used in that context because when doing things over the internet, we frequently need this sort of simple way to represent some pretty complex ideas. And this is a super simple way. So there, I gave you an example of XML. We have discussed it before, but technically it doesn't. You wouldn't actually need to be taught this, right? Like anyone who's literate would be able to read this thing on the left here. Like if you just read through the lines of that XML, you can see what it's intending to represent, right? Like, for example, I can say, what should I say? There are two, I don't even have to be specific. There are two entities represented on this list. What are their names? Tesla and NIO, precisely, yeah. So exactly, there's two companies represented on the list. You can see that there's their stock price. I mean, I don't have to explain this to you guys. You can read it. Okay, so that's one example of XML, and that's perfectly legitimate. You can represent that data in that way. In fact, you probably would represent that data in that way. And on the right here, I forgot what I was doing here. Okay, yeah, I was, okay, these are some Reddit posts, I think. Yeah, okay, so cool. But there's some other structured data on the right there, or images that were posted to Reddit by a particular user with a particular description. Yeah, that's what that's intended to represent. And yeah, so basically it doesn't need to be super explained to you. Well, yeah, I was trying to think of interesting examples to use XML for rather than like the standard boring ones. So yeah, I figured this is okay. Anyway, so but yeah, the specific example doesn't really matter. I don't think I've ever made my own Reddit post. So 0 for me. I don't know how much these guys have. They were pretty funny pictures though. So cool. So the extensible in XML, so XML stands for extensible markup language. The reason we call it extensible is because you can just make up your own tags, right? Like you guys have seen HTML, right? And in HTML, we can't just make up our own tags, right? The tags have a fixed meaning. Body in HTML means something. All of the tags in HTML have a specific set meaning. You can't just make up your own tag. Like it doesn't work that way. But in XML, you can just you can make a tag called whatever you want. And so we call it extensible because you can extend it, right? Like you can extend the list of tags that XML supports. All right. So there's that. The first line, again, you don't have to think about this too much because it's always the same. But the first line is what's called the XML declaration. So like if you see them use the term XML declaration inside a question, you know they're talking about this first line. They're also sometimes referred to as the processing instructions because you're specifying the version of XML you're using and the encoding that you're using. So like how it's encoded for the computer. And yeah, so essentially that's just whatever. Just remember that these names are how we refer to this first line in an XML document, mostly just because you can be asked about it. So yeah. And cool. So the other important just name to remember, and then we can get into actually using some XML, is that any sort of tag, so from like the start tag to the end tag, it doesn't matter if it spans multiple lines, because obviously the fact that it's on a new line is kind of irrelevant. But like anything spanning from like a start tag to its end tag, so like company to /company, or desk to /desk, or companies to /companies, any sort of start tag to end tag is called an XML element, a single element of XML. Just remember the name elements because we will use it inside the code that we're about to write. Okay. So yeah, that's all the theory you really have to know about XML, and there isn't much because it's pretty obvious to read, right? The last thing, I suppose, is how we actually read XML in C#, but we'll get back to this. So anyway, I wrote up a quick XML document over here. So this is called emails. I'm gonna open with text editor, notepad. Yeah, okay. So you see, I've got that there. Again, I probably don't have to explain it to you guys because it's pretty obvious what this is attempting to represent. So it's emails. This is also probably how you would do this, practically speaking. So yeah, we've got a to, a from, a subject, and a body, okay? And then we've got like an email. They've each got their little ID, which interestingly, we wouldn't have to put the ID here, right? But because we're referring to databases, does anyone know? So what would we call that ID column inside databases, just to make sure everyone's awake? Why is that ID there at the beginning of the tag? Yeah, exactly. That could be translated into the primary key. If we wanted to translate this XML into a database, we could have like a table called emails or even email, whatever you liked. And then the ID could be set as the primary key, right? So you can see that like normally there wouldn't be like an obvious primary key anyway. Cool. So yeah, that's some XML. We don't have to talk about it too much. What we just want to do is think a little bit. We're not going to go into huge amounts of detail because ultimately, if you wanted to read XML or anything like a text file or a database or a data set, it's always going to be super finicky. We can't possibly cover like every little thing, but I'm going to give you a basic idea of how you might work through this problem yourself. If we were trying to read XML into C# or write XML from C#, you know, how would we do that? That's basically what we're going to discuss at the start of today's lecture. So for XML, and remember this, so it's in bold on the slide, so you know, don't forget it. In C#, there is a namespace called or saved at system.xml, system.xml. Okay, inside system.xml, we have something called an XML reader and another thing called an XML writer. Okay, so we will discuss a little bit in more detail what these are doing later on when we get to files. Again, we're going to go back to files just briefly. And yeah, so we'll discuss that a little bit later. But so we'll discuss in more detail what these are doing. But at a basic level, you can kind of see what they're doing, right? And the XML reader will read an XML file and the XML writer will write to an XML file. So anyway, without further ado, let's actually do something. So I'm going to create a new console app inside C# and hopefully everything just works. The solution, we'll save it in workspace. I'll call it Crawford 06. The final lecture. Wow, we've come a long way. More than 19 lectures. I've got 19 sets of slides, but I guess that translates more into like 25. Yeah, I'm just waiting for a high assist on this. What? Huh? Okay, sorry, someone's missed. Oh, okay. Cool. Let me just double check something. Sorry, guys, just a logistic problem. Okay, hold on. I'll deal with that in the break because I just got 2 messages. Anyway, so let's just focus on this, and I'll solve that during the break. Cool. So we're going to read this XML file into our console. I'll show you briefly how we work with it. At the end of chapter 3, we covered, was it chapter 3? Chapter 2? No, chapter 3. At the end of chapter 3 on data structures, I showed you guys one new data structure. Do you remember what it was? I showed you guys one new data structure. It was just for fun, and you won't be tested on it directly. Does anyone remember what that data structure was called? Yeesh. I did think Adam would be the one to remember. Yeah. So it is dictionary. Maya remembered as well. Cool. Yeah, it is a dictionary. It is a dictionary. Nicely done, guys. Yeah, and that's basically, that's going to play a big role in today's lecture, which is why I said that we might be able to end early, because you guys do kind of know this. But yeah, anyway, so in order to work with XML documents, we have to say using, you can see maybe a similar example on page 167 of your textbook. Slightly different though, because they're reading a different XML file, obviously. So I'm going to say using system.xml. That's the first thing. Obviously, we need to know what namespace we're using. And you can see it should give us a little blurb. Will it? I think because okay, never mind. Doesn't matter. So cool. That's where all of the classes and methods and stuff that we're going to need to work with XML documents will be saved. The next thing is to literally just open up the file inside C#, and this is fairly easy to do, right? We have a bunch of objects, okay, or a bunch of classes inside system.xml. From those classes, we have to create instances of them, which are called objects, as you guys know from way back in chapter 2. So we're going to create an XML reader object because it will be able to read XML, as its name implies. And we'll call it reader, because why not? And we'll say XML reader. Ooh, so this is going to be slightly different, but actually you guys will be able to tell me why it's slightly different. So let me just read this quickly. So, okay, let's read this together, this little blurb that things brings up, because this is actually pretty good revision. So it says represents a reader that provides fast, non-cached, forward-only access to XML data. I'll explain what the forward-only means. Fast is kind of self-explanatory. Non-cached, it's so you don't have to know what non-cached is. You probably have some kind of idea because we did discuss cache memory briefly. To browse the .NET Framework source code for this type, see the reference source. Cool. And the big thing is what it says on the next bit. You cannot create an instance. Oh, damn it, it gave away the answer. Oh, I was hoping that it wouldn't. So it says you cannot create an instance of the abstract class or interface XML reader. So I was actually going to ask you guys, why can't we create an instance of this class? So like, I can't use the word new because it is, you can't create an instance of this type. But so cool. So what we say is we create an XML reader using this create method. Ooh, I can ask you this. What keyword would the create method be instantiated with? Since you notice I haven't created an object of type XML reader. Yeah, okay, yeah, that's correct. So it is an abstract class, but somehow I'm able to call this create method, even though I haven't created an object of type XML reader. Does anyone know how that create method was override? I mean, look, we're in the right place, but let's think about this. How do we say that this method belongs to the class and not the object. What keyword is it, guys? How do we call, it's actually on the screen as well, because it's a method that we can use without creating an object of the class. So it's inside a particular class, an abstract method. Not quite, because create is implemented, Adam. Create is implemented. So I mean, look at the class that we're in currently. We're inside class program. The computer calls, what's the first method that the computer calls? Is there a program class associated with it? I might be giving too much away. So the main method is called without a program class that exists. Why can it be called with that? So void means it doesn't return anything. Okay, you've basically reduced all the possible options now. Okay, guys, so remember, static means that it can be called without creating an object of that type. Okay, cool. But anyway, so create, great stuff. So what does create do? So it creates a new XML reader instance with the specified URL. Not too bad. Okay, so we can just give it some input. We're going to give it, so we need to tell it about this file, emails.xml. So we're just going to say, okay, you go over and you read emails.xml. Okay. Okay, so that's just telling it we're going to go read. I know we spent a lot of time on that, but I think it's fairly good revision. Cool. So now it's actually pretty easy. We can now just read from this reader because it provides forward-only access. So what that means, it's kind of like a linked list. You can only move forward through the file. When you read, so when I say reader.read, it's going to read the first line of the file. Okay, when I say reader.read, like that, that will read the first line of the file. Okay, and what it's saying is that it's forward only. So it's going to read that first line, and then it'll go to the next line, and then it'll go to the next line. And as it suggests, forward only, you're not allowed to go back. Okay, there's no going back. So you have to process it all in order. Okay, so we're going to say reader.read. Great stuff. So while reader.read, okay, so this is just saying while there is a line to read, do this with that line. Okay, while there is a line to read, just do this with that line. Okay. And all we're going to do to start is we're going to say, yeah, actually, we can just start by doing that. A fairly simple thing. So I'm going to say console.writeLine reader.name. Okay, reader.name. And let's see what this prints out. Okay, let's see what this simple program does. So I'm going to build the solution. Build. Okay, so it just told me where it built to. So I'm just going to jump there in CMD. I'm also going to move emails.xml so that it's in the same sort of directory as that other thing. So we're going to jump over there. This is where it is, console app1.exe. That's our little app. So I'm just going to put emails.xml here. I'm going to copy the URL to this directory. I'm going to open up a command prompt and just change directory to that directory. Okay, so there we are. And then we can just run console app1 and you can see what it prints out. Ooh, okay, console app1. Okay, so you can see what it prints out. So what is this doing? Let's just see. Okay, so I printed out reader.name, if you'll recall. So it printed out emails. Oh, sorry, I need to scroll up a little bit. So it printed out XML because that's the first name of the tag. Then emails, then email, then to, from, subject, body. Ooh, but notice what it's doing, guys. So it says to. So it printed out email, then it printed out to, and then to again. Interesting. So it's accessing all of the things contained within emails sort of in the correct order. Okay. So you can see like it opens. Oh, you know what? Okay, I was being silly there. Why is it there twice? Good question, Alex. So, and yeah, it confused me briefly, but it makes a lot of sense, okay? Because it appears in the file twice, Okay, so you can see that each XML tag has a start and an end, right? Is it not? It is opening and closing it, exactly, Rahan. I'm sorry, I was briefly confused. Not sure why. So emails, email to, and then close, from, subject, subject. So it's reading through each tag, okay, each tag, if that makes sense. So to, it reads in the value as well, but we're only printing out the name, if you guys recall. And then it prints out closing the to tag, opening from, closing from, etc. And it moves through the file in order. Okay, and you can see the last tag is called emails, and it is called emails, right? So makes sense, fairly sensible. So now we know what this is giving us. We know what reader.name is giving us. Okay, so reader.name, we can see what the other options were. So for properties, there was there's this interesting one here called is start element, which we'll use later. So it can give us the table name. It can give us a bunch of interesting stuff. Okay, so there's a lot that this class can do. There's a few things that we care about specifically. Okay, so when we want to process XML, what we really care about, like as Rahan pointed out more clearly than I did. So this is saying this is an opening tag and this is a closing tag. This is an opening tag and this is a closing tag. So what matters to us is, can we tell if it is an opening tag or a closing tag? Because obviously we only want to process the item once, right? We only want to process the item once. You don't want to process it twice, because this just looks a bit weird. Like you wouldn't want two to's and two froms, okay? And so it provides us this way of checking whether the elements we're working with is a start element, okay? So you can say reader.is start element, and you can read the little blurb here. It says calls XML reader.move to content and tests if the current content node is a start tag or empty elements tag. Okay, so it's checking it if it's checking if it's a start tag, essentially. So you guys can see what this returns is Boolean, so it's true or false. So how can I test this, guys? If I want to check, I want to do, okay, no, that's a silly question. You guys will all know the answer to that. So I'm just going to say if it is a start element. Okay, so we're only going to process it if reader.is start element. Okay, we're only going to process it in that case. So it's just saying, is this the opening tag? Is this the opening tag? Okay. And now let's just print out console.write line name again, to see what we're working with. Okay, so sorry, we're going to say reader.name. Okay, so that's just a property that exists. Okay, I'm going to run it, and you can see now it's much more meaningful. It gives us emails, email to from subject body, email to from subject body. Okay, so now it's only giving us the first tag, not the closing tag as well. And you can see it's in the correct order now. Okay, so just to from subject body. Okay, so that makes a lot of sense as well. Now we can check. Okay, so what we want to do, we have a pretty complex decision to make here. Okay, let's say, so in your book, they only print out like the company name and the phone. Let's say I only want to print out the subject and the body. Why didn't it end the emails though? Because the closing emails tag, look, it didn't end any of the tags this time. See, Alex, because we only printed out the start element. Yeah, you see previously it did close emails. Cool. So now what we want to do is, so this is essentially telling us like which tag we're processing. So what we're going to do is say, all right, I just want to print out the subject and the body. Okay, the subject and the body. No problem, no problem. So I just want to print out the subject and the body. Okay. Let's say, hypothetically, I mean, you could pick what you wanted to print out. But yeah, let's say we only want to print out the subject and the body. So there's multiple ways to do this. We could check if reader.name equals subject, or if reader.name equals body, then we can do something inside that if statement, right? But guys, you guys remember, right? That's not the best way to handle this kind of decision. What other decision structure can we use to process this kind of more complex decision, where it's possible that we could be processing to or body or subject or whatever, right? So what should we do? Precisely. We're going to use a switch statement. Okay. Cool. So I'm going to say switch, and the thing that we are evaluating, that we're switching over, is reader.name. See, so that's what I mean. This is not the most interesting thing to save for the last lecture. At least I personally think so. But it is a good way to sort of summarize everything we've learned, because there is a lot going on here that you guys would not have known at the start of the course. So if reader.name is subject, for example, so case subject, then we're going to do a certain thing. I'm going to leave it for now, though, so just going to break over it. We're going to say if it is the body, and how do I handle all other cases, guys? How do I handle all other cases? Nice. Yeah, defaults. Okay. Cool. In this case, we don't actually need a default, but I was just testing you guys. Okay. Cool. I mean, I guess we could use a default for something. What would we use it for? I mean, nothing really. As long as you guys know it exists, we don't have to use it. Okay. So console.writeLine, we're just going to say, all right, we've got, if it's a subject, let's just make sure that it knows that it's a subject. So we'll say subject is this, and I'm gonna use this fancy sort of formatting thing that you guys have seen before. Although, yeah, that's fine. So we're gonna give it the, all right. There are two ways to do this. The way that they use in your book is they take the reader.value. I think there is a nice one as well that's like reader.inner XML, which makes more sense, right? Because it's like inner XML is obviously the thing inside the XML tag, but we should use the one that you'll be tested on, obviously. So we're going to use reader.value, okay? So the value is the thing. You can just read the blurb. It'll probably describe it better than I can. Gets the text value of the current node, okay? The text value of the current node. So you can picture that's like the text inside the XML elements. Don't ask me why they're calling them nodes and not XML elements. The official name is XML elements, okay? Cool. And we'll basically do the exact same thing for body, except we'll print out body, okay? So it'll be like body and then whatever we're printing out. So body like so, okay? And now we can build this little solution and we can go and run it again. Ooh, it didn't get the value. That's interesting. I'm very confused now. What is going on here? This is weird. Sorry, guys. Let me think. Case bodies, case subject. Okay, let's just, I'm going to do something simpler quick, just to make sure that things are working. Live demonstrations, gotta love it. Gets the text value of the current node. I mean, that makes a lot of sense. Need to build it again, obviously. Okay, so here reader.value did work. So I take it we were just doing something wrong. Let's just try again. Okay. Hold on. Oh, we need to read the next line, obviously. Okay, sorry guys, I was being silly. So yeah, we need to actually read the next line before we printed it out. So let me just make sense of what's happening here for you guys. So it's reading in the elements, so like the name of the start tag, and then it's reading in the value. But you need to run reader.read again before it gets the actual elements. So I'll just show you what we need to do. We need to say reader.read over here. Okay, something like that. and reader.read over here should work. We should probably throw those in if statements just to be safer, but that should work effectively as well. Yeah, there we go. Okay, so it says subject, plans, body, want to get some breakfast, subject, job offer, body, you got the job, when are you coming back to South Africa? Okay, cool. So that's reading XML documents. Sorry about that. Let me just make sure that that makes sense to you guys. So we get the reader.name, so that gives us the name of the tag, but then we just said, okay, if it's a subject, get reader.value, but the tag itself does not have a text value, right? Like the tag itself is just the tag. It has a name, it doesn't have the tag. So we have to run reader.read again to read like the text that is saved inside the tag. Are you guys comfortable with that? And sorry that I forgot, but yeah, hopefully that makes sense to you guys. If not, you can feel free to ask. Cool. So yeah, that's that. Let's now move swiftly on. What is, so we started at 15:20. Okay, we've still got some time. Okay, so yeah, I told you that we would be doing things in slightly different order. So cool, we've got in system.xml, there's XML reader and writer. There's also this other idea that we need to get across currently. So what I've done, I'll lay the groundworks first. So I've set up a database on my computer. Let's just connect to it. Okay, you can see it's connected. So this is like a default database. It's a very, very large database that we're going to be working with. Okay, so this is just going to demonstrate to us how to work with databases inside C#. Okay, so we have this database. It's called AdventureWorks. Okay, it's got lots of tables. I'm going to open the list of tables. That's all the tables it has. You can see that there are a great many tables. Lots and lots and lots and lots. This database is a little bit different. It's got a pretty, wow, there are seriously a lot of tables. Okay, there you go. That's where they end. So this is a bit of like an object-oriented database in a way. The schema is a little bit different from the databases that we've seen before, but it'll still make sense to you, and I'll explain what's going on. We'll mostly be working with this person table. Okay, so there's a bunch of things. You can see that they've got a name of a table, so contact type, and then a little object next to it. That's what I mean by like object-oriented table. So it's like the person object has multiple tables associated with it. It has a contact type, a country region, an email address, blah, 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 a person phone, a phone number, state, and province, and that's all. Okay, so we'll mostly be working within that sort of object because it is like quite a large table. I think let's just write a query. So let's just make sure the table is working, then we'll take a little break. So how are we going to make sure that the table is working? I want to test if we are connected to the table, it's connected to the database. So I want to get everything that is inside the person table. What SQL statement will I use to do that? What SQL statement would I use to go and get everything from the person table? Nice. Yo, even the star. Good stuff. So what I'm going to do, I'm going to right click over here and I'm going to say new query. Okay. And this is going to open up like a little SQL editor inside Visual Studio. Cool. And we are literally just going to write select star from, and usually how it would work is you'd just be like, okay, we're going to go and get stuff from the person table. Okay. We're going to go get stuff from the person table. And that makes sense. But in this particular case, because this is like, you know, there's a lot of potential options that it could go to here. We need to be a little bit more specific. We need to tell it which database we're going to, which object we're looking for, and which table we're looking for. So the database's name is AdventureWorks, okay? The object's name is person, and we're looking for the person table inside person, okay? So it makes the query a little bit longer, but hopefully you guys get it, okay? Ooh. Wait, that's what we haven't. Okay, we'll do so after the break. I haven't shown you guys stored procedures yet. I remember we didn't finish it in the last lecture. Hey. Okay. Anyway, so we ran this query, and you can see that it gives us this whole thing, a lot of stuff. Okay. So you can see this table has a lot of people. This database has a lot of people stored inside. it. So there are, let's just expand this out so that we can see the number. Okay, there are 19,972 people stored in this database. Okay, so yeah, there's a lot. Cool. So we're working with a pretty large amount of data here, but you can see that it's still the same. The query is still super simple, right? And if we wanted to search for a specific name, are the people randomly generated? Yeah, I think they are, because there are like one test I did, like we can say, how would I add a condition, guys? Like, what if I only wanted to see particular people? What would I add? Where condition. Yeah, exactly. So we're going to say where first name. Okay, Maya wouldn't be a common first name. Rahan wouldn't either. I reckon there's an Adam or an Alex somewhere in this table, right? So let's search for that. Where first name equals Adam. Okay, there are 53 Adams. I assume it's randomly generated. Definitely, it's definitely randomly generated. 53 Adams in the table. Cool. And cool. So that's working. We are able to query the table, but you can see this is still a standard SQL query. We want an SQL query that we probably not, Judd. So we want to run these SQL queries from our actual console app. Wait, so we usually go for 45 minutes. I'm struggling to tell what the time. So we started at 4:20. So yeah, we have been going for 45 minutes. So we should probably take a little break. So yeah, let's do like a 5-minute break, because I realize now that I also need to show you guys stored procedures. Although I'm not in a rush at all anymore. Maybe you can tell from my voice, because we are way ahead of schedule. So like, even if we have to seep into next week's lecture a little bit, like the revision lecture. So yeah, we'll take a little break. Oh wait, 16:05 is the current time. What am I doing? 16:10, we'll come back. Okay. Oh, we started at 3:20 as well. That lets you know where my psychology is at. Mm. 6-minute break. Are you insistent? Need a 6-minute break. 5-minute break is unfair. So you should. I mean, they say Lee's the most. There's that old. That would be like a surname, right? You can try some others. But this table, oh, okay, there are a lot of Lees. 88. Huh? Figured that there wouldn't be, since it's obviously an American thing, I assume. Nice. $88. But yeah, we'll play with the table. I'll try gift. I highly doubt that will be in the database. Although, I mean, you never know with like a random generator. Nope. There would be an Alex, right? Although maybe there'd be full name. Okay, no, there's lots of Alexes. 51. Andrew. $31. What about me? Am I 26 Joshua's? Pretty good. So Oh, yeah, we'll get to that later. Damn, yeah, I forgot that I hadn't shown you guys stored procedures yet. How do we think about this? I mean, it is just a query that you can save on your own system. So it's not really that special, to be honest. It's like a method, but in SQL. Should I show you this? I can show it to you next time. And you guys, oh, that's the other thing that I needed to tell you guys about. The those understanding databases modules, those whole things, that thing I sent you. By the way, was it too long? Was it nice? I don't know. I mean, I went through it, but it's difficult to gauge. I thought it was quite cool. There's a lot in there though. Like you could spend a good like hour and a half going through all that stuff. I didn't watch the videos, but I think it was quite cool. It's a nice resource. Especially the multiple choice questions are good to do. Ah, 10 past 4. Okay, we can clearly no one wants to discuss the homework, which is a little bit suspicious, but that's fine. Can't say I'm that surprised. Anyway, okay, so we have a SQL statement here, but in order to actually use that inside C#, quite obviously we need to connect to the database first. So I'm going to use the same sort of method over here. Rather, I'm just going to remove this, to be honest. Okay, let me ask you this first, though. So there are sort of two sides of this connection, right? Like the connection to the database. There's two sides of it, right? Like the database is the one side, and it's on what? What is the database on? What do we call it? What is the database on? Anyone? If you guys remember, there's that little graphic. It's how we always handle sort of connections. There's a request and a response. What are the two sides of that relationship? Because it's quite important for just remembering what the namespace inside the class, what the namespace inside the application we'll be creating is called. So what are the two sides of that sort of response request relationship that we learned about under web development? I'll wait. Okay, we did end up having a 12-minute break, I guess. Can't remember. Huh, that's tough. Okay. What do you run a website on? What do you run a website on? Okay, you run it on a browser. Okay, yeah. Okay, as a developer, a server, precisely. Yes, server is what I was looking for. Cool. And so what's the other side of that sort of connection? What's the other side of that relationship? There's the server that holds the database, and there's the client. Yes, okay, cool. Glad we got through that. Cool. So yeah, when we're connecting to a database, we also have the server-client relationship. So the database is seen as being on the server, and you connect to it from the client, like from your application is the client, okay? And so the namespace we use, it should be easy for you guys to remember. It's system.data.sql clients, okay? So it provides a whole bunch of classes that are useful for you if you are a client accessing an SQL database, Okay, and this is the code. It's very simple to create a code that will access a database and run a particular query. So let's just do it now and see what happens. Okay, so the first thing we need to actually connect to a database, and this is the important thing, is the connection string. Okay, it's almost like a URL for a database in a way, I guess, or it tells you where to find the database. It tells your app where to find the database. Where do we get the connection string? Inside, okay, where would this be? Gonna have to find this somehow. Are we able to? If I say connect. Okay, it should be under like properties or something, I think. Ah, there we go, properties, cool. You can see here is what we have called the connection string, okay, the connection string. So the connection string is just telling us where to find the database, and it's got some pretty, it's pretty weirdly formatted. We don't have to discuss it too much. You guys just need to know what it's called. But let's just write it out. So string connection string equals that. So that is specifying where the database is. So it's saying source equals user PC. That's just the name of my PC, because obviously my PC is the server in this case. Catalog equals AdventureWorks, because AdventureWorks is the name of the database that we're accessing. Security equals true. This probably just has something to do with encryption, something like that. And yeah, so cool. That's how the app knows where the database is. It's called the connection string. I think you guys could probably remember the name fairly easily, hopefully. And yeah, cool. So we just open a connection using that. We need to import using, or say using system.xml, .data .sql clients. Okay, SQL client, like so. So that's going to give us a bunch of classes and stuff related to working with databases. And now we literally just open a connection. So it's in the slide. We'll go through each little bit. So we say string connection string. So that's telling us where the database is. We then open up an SQL connection object. So that's going to actually go ahead and connect to the database. Now, if you guys recall, this might be a pretty high risk operation, right? Like connecting to a database, a lot can go wrong. The server can be broken. Your internet connection can be broken. A whole lot of things could be broken. The connection string could be formatted slightly incorrectly. So guys, when we're running the super high risk operation, what do we use? Where do I put this code? You can see the code here has been sort of separated from its surrounding context, but in what expression would I put this code, since it's so dangerous to run, like so much can go wrong? Where do I put it? Anyone have any ideas? Some people are having memories that can go pretty far back. That's cool. Glad you guys remembered, and that is correct. Yeah, so we're going to throw all this into a try catch statements, okay, because it's dangerous. It's dangerous to connect to databases. So all of it is going into a try catch statements, and our catch statements is just going to catch any error that occurs. Yeah, any exception that occurs, rather. And it'll just print out the sort of standard error message. So e.message, okay, like so. Cool, so it's inside a try catch statement because it's dangerous. Hey, wow, Andrew even wrote out exception E, nice, yeah. That took me a while. So yeah, we've got that. Let's open up the connection. That's the super high risk bit. So we're going to say SQL connection. So this is just an object that keeps open a SQL connection. Wow, it even gives us a nice name, Okay, SQL connection's a bit long to type. Oh, they recommend connection. Okay, we'll call it connection and we'll say new SQL connection. And what does it require? It requires, if we open up the little blurb that Visual Studio will give us, it requires a connection string. Okay. So we give it the connection string. So that's the database that it's going to go and connect to. And yeah, that makes sense. I can't hear at all. I'll try join from my phone. Wow. Lots of audio problems. The rest of you still okay? I guess I could turn up my mic a little bit, but I think it's pretty loud already. Cool. So now we need to actually give it the query that we're going to run. And so this now SQL client gives us another object. It's an object called SQL command. And you can see its little description. It says represents a transact SQL statement or stored procedure to execute against a SQL server database. Okay, we haven't learned about stored procedures yet, but what it means by transact SQL is basically just an SQL query, exactly how all the other SQL queries you guys have seen before look. So we're going to say SQL command. We're going to create this object quick. So we'll say SQL command equals new SQL command. And and again, I run into this issue. It's because I've gotten so used to creating instances this way. But you'll notice it says this class cannot be inherited. In fact, it also can't be instantiated in that way because it is, that's not how it works. Okay, so we just use it. So we'll say equals connection. So the reason it works this way is because every single SQL command, as you might predict, needs to be linked to an SQL connection. So how you do it is you say connection dot create command, and you can see what type, just from what you guys know of, just of what you guys know from how to read methods, what type, well, yeah, no, in this case, no, because this case, I did create a thing of type connection, right? You see that. I did create an object of type connection. But what type is SQL connection returning? If you just look at its little declaration over there. What type is it returning? So in this case, if I call SQL connection.create command, what type is it returning? Just by looking at it there. It's returning, you can see there, it's returning an SQL command. Okay, I also bottled that, so don't feel bad. But you can see, so what this does, it says it creates and returns an SQL command object associated with the SQL connection. So all this is saying is every single SQL command has to be linked to a particular connection to a particular database, okay? So this connection.create command is just going to create a command that will be able to run on this SQL connection, like run over that SQL connection. It'll make a lot more sense just now, okay? So what we then do is we give it the command that we'll want to run. So we're going to say command text equals, and we're going to give it a string, okay? And this string is literally just whatever SQL query you want, okay? It's literally just whatever SQL query you want. So literally in the standard format, exactly how you've seen it before. So what we're going to do, we've tested this query out over here, select star from adventureworks.person.person. In fact, we did a more fun one. So we'll keep our little where statement, where first name equals Adam. Okay, so we've got our SQL command here. It's formatted exactly correctly. It runs. We've even tested it. Okay, I'm going to copy it, Control C, and just put it as the command text right over there, okay? It is exactly a normal SQL query, right? You guys see that, exactly a normal SQL query. Oh, minus the semicolon, okay? You guys will also notice that maybe what's weird about this? What's weird about the where statement, guys? What's weird about the where statement from what you guys have seen before? I'll throw in a little space there just to make it clearer. What's weird about that? where first name equals Adam. It looks pretty standard, but there's one difference from what we've seen previously, from what I've told you before. Okay, I'll just tell you, maybe the question's too vague. You can see that Adam is in single, it's not high. Actually, in a way, yeah, that is also another difference. So I suppose there was more than one difference. But yeah, you can see that the Adam is in single quotes, okay? Adam is in single quotes. The reason it's in single quotes is because the entire expression is a string inside C#, and there's no way that it would be able to tell the difference. Exactly. There's no way for it to be able to tell the difference between single and double quotes. So in standard SQL, we would put Adam in double quotes because it's a string, right? But in this case, because the entire expression is inside a string, we have to find a way to differentiate between the quotes inside the query and the quotes outside the query, right? Because if I went to the beginning of Adam here and I made that double quotes instead, you can see it doesn't know, like Adam is now no longer in the string because the string is being closed there. So we use single quotes for the strings inside the query and double quotes for the strings outside the query. Okay, but anyway, cool. So that's that. We've got our little SQL query, and now we can just run the query. So we're going to open the connection to the database, connection.open, and obviously there's a lot going on in the background there, but yeah, we don't have to discuss that. Now there's a type that there's two types that allow you to read the response of a query. The one we're going to discuss first is the SQL data reader. Okay. So you can see that this is forward only, exactly like our XML one. So it's forward only. You can only go forward through the responses. SO for inside a string. Yeah, exactly. But you see, usually that would mean character. Usually that would mean a character. But because we're working in C#, that's just one slight difference that they made. But you can understand why they did it is the important thing. So SQL data reader, it's forward only. We can only go forward through the response. So we're going to create an SQL data reader. It works a lot like the XML reader. Except now we say, okay, we're going to take the command, and remember the command is linked to the connection itself, and we're going to execute it. Okay, so you can see we've got the standard worded query, and this then sends the SQL command to the server, executes it, and then saves the response into the SQL data reader. Okay. There are three ways that we can execute a command. I'm going to discuss them quickly with you now. So there are three ways we can execute the command. We can either execute reader, execute scalar, or execute non-query. Okay, this I would say is probably the hardest part of this section, the difference between these three things and why we'd use each one of them. But yeah, let's just sort of go through them. Okay, so execute reader is what you would expect. Everyone is getting executed. So execute reader is what you would expect. It just takes the query to the database, executes it, and gives you the entire response back. So let's play with that one first because that one makes the most sense. So we're going to say execute reader, and it will just return the entire response into this SQL data reader. Okay. Then what we'll be able to do is just literally go over this reader in the exact same way that we did previously. So what we're going to do is we'll say while reader.read, so like while there is still a row in the response to read. Okay, so while reader.read. Then we're just going to use the response. Okay, so I'm just going to say console.writeLine. Let's say we want to print out the surname. So because of this, we know their first name is Adam, right? Because we said where first name equals Adam. So we're just going to print out their surname. So what I'm going to do is say this. We'll do this 0 and say reader.getValue. Oh, okay. No, I understand why I'm a little bit stuck here. So we need to discuss something else. Okay, look at this table. What it's going to do when it responds, it's going to give you the tables in order, like as if they were an array. So guys, what elements, what index am I going to have to get in order to get last name? I'll let you guys do the counting for me. In order to get last name, what index am I going to have to get? If you look at this, so it'll be in order of columns as if it were in an array. 7, 6. Okay, I'll just count as well, but I imagine it's in that region. So 0 is business entity ID. 1, 2, 3, 4, 5, 6. Okay, so 6. So we're going to say reader.getValue in position 6, okay, because we're looking for the 6th column. Obviously, if we just said select last name from, then it would just be 0. So if you're worried, happens to the best of us, Christian. Don't worry about it. So yeah, got that. Cool. You guys get that. So we're just going to build the solution and hopefully it works. Okay, so we're going to get the surnames of all the Adams in the database. That's what this is going to do. Except we're doing it in a inside a C# application instead. Okay, so run it, and you can see, we don't have to check, but those are all the surnames of all the Adams in our database. Okay, so wow, there's an Adam Adams. That's an interesting one, Adam Adams. But yeah. Cool. So our SQL query is working. And yeah, that's good. Cool. So got that. What we are going to do next is say, okay, so that's how we run a query. That's how we connect to a database. Actually, that's it for this slide. Cool. We are making pretty good progress. I don't know how I thought we would end early. So the next thing we need to discuss is a thing called flat files. Okay, so flat files, why they call them flat files is beyond me. Okay, basically they just needed a word for files that includes text files but is not limited to text files, if that makes sense. I'm not sure how it could, but yeah, so it's like, yeah, okay, cool. So basically we can store a database table inside just a standard file, like a .txt or even an XML file. We can store an entire database into one of these files. And when we do that, we call it a flat file. Okay, when we store a database table inside a text file, for example, or even part of a database table inside a text file, we call it a flat file. And what we're able to do with this sort of, or even parts of a database table, essentially it's just like using a text file in relation to a database. You call it a flat file. But there's also other types of files you can use, like even XML would probably, you would call that an XML file, but you could also refer to it as a flat file. So yeah, we are going to be working with that a little bit, but yeah, we're going to be working with flat files. But in order to do that, I'm going to have to revisit a concept that we discussed a while back with streams. So it's like a copy of the table, so you can use it to test manipulation. Yeah, I suppose. So actually, what you're describing there, Adam, we'll see more closely in a little bit. That's called a C# data set. So that allows you to actually manipulate the data inside the system's memory. Okay, but this is more like storing it in another format. So like .csv or .txt. So like if someone is asking you to take some of the results from your query, so like a table basically, because you get the response in a table. If they're telling you to take that response and save it in an Excel spreadsheet, then you would say, okay, I'm working with flat files, something like that. Okay. In general, it's a fairly vague term, which is why I didn't really want to introduce it, but you have to know what it means. There's the formal definition that they'll use is on page 164. Okay. And it's cool. So how we basically work with them, you guys have kind of seen it before. It's inside the system.io namespace, and it's called streams and backing stores. We're going to discuss streams a little bit more in detail now. So it's almost like a stream of water, except in your memory. Okay, so it's flowing from somewhere to somewhere. That's why it's called a stream. And you guys remember we had that word forward only, because it's like the stream only moves forward, right? You only go down, you go reader.read. There's no going back. Like once you've processed that piece of data, there's no going back. It's been processed. Okay. So it's similar to a stream, basically. Stream is a good name for it. So system.io provides a lot of ways for working with streams. You've also just seen XML Reader provides a stream for XML documents. But yeah, so system.io is the main place we look for things to work with streams. And there are two aspects of a stream. So there's the stream itself, which is like the data that's waiting to be processed in that forward-only manner. And then there's what we call backing stores. And that's basically either the source or destination of the stream. Okay, so just as some examples that you guys have seen, we could go from the database into the stream, into the file. Okay, so our stream is running from the database to a file, for example. You could also go from a file to the console, right? You've seen this example before. We did this in chapter 5, where we read from a file and we outputted the contents of that text file into a console. So that was also a stream because it was running from the backing store of the file to the backing store of the console, and it flows in a stream. Okay, that's what we call it. So there are a bunch of streams that you could work with. The one is just stream reader and stream writer. These we use for files. Okay, we used file reader in chapter 5, but it's the same basically. So we've got stream reader and stream writer inside system.io. Okay, obviously for reading and writing from and to text files. So text files, we just need to discuss these little advantages. I don't want to spend too much time on this because it's also good to free up time for revision and stuff. But the sort of important aspect of this is to say what the advantages of a text file are, basically. Like, when would you use a text file? The biggest advantage about them is that they're human readable, they're easy to understand, okay? Or can we phrase this different? Yeah, you could even remember, Adam, so actually it was you who asked that question once before, like how would we load data into a database, right? Like you might have, when you do a poll, it's highly unlikely that the market research person who's doing the poll is savvy enough to actually create an online database, right? Like they would probably give you a CSV file or even maybe a text file that holds all of the different responses from all of the people who responded to you. And a stream is how we would read that text file into a database, right? Like you could also flip this around. You could have the file being the source and the database being the destination. Okay, cool. Yeah, so you could do it that way. You could also do it in this instance. We're going to do it this way because that's the way that they do it in your book as well. But yeah, you can read an XML file directly into a database, and it'll just create like a table called emails, for example, and you can see in your head how that would operate, right? So yeah, cool. I'm glad it makes sense. Okay, so the huge advantage of saving things in text files is that they're human readable, they're super easy to understand. But what you can imagine is, okay, hopefully no one read the slide. But like, what would be the weakness, guys? What type of data would I want to store that I wouldn't like, that we store in databases? Like, let's think about YouTube, for example. What data does YouTube store in their database? Does it make sense? User data, yeah, user data we could store in a text file quite reasonably though, right? You could have like their first name, comma, their surname, comma. Exactly, videos are a big one, but also like anything, right? Images, sounds, it doesn't make sense at all to represent those in text files, right? Like at all, because it's just, no human can read that anyway. Like how would you represent a video in a text file? Obviously you would have like a long line of bits, right? There'd be lots of bits, but it's pointless storing that in a text file. So when we're storing that kind of data, we use binary reader and binary writer, which is exactly the same as text files, except with binary. So it's ones and zeros. It will be a book then. Yeah, it would be a very long text file. That's true. Yeah, so the binary reader and binary writer, it's not human readable. It's faster for the computer to work with. And this is how a binary reader and a binary writer is probably how we would store pictures and videos and sounds inside flat files. which is this kind of thing would be frequently done. We'll discuss it a little bit more when we get onto data sets. But yeah, cool. For now, that's good. In the last 12 minutes, hopefully I can just show you the simple example of just going from. Okay, what we're going to do, I'm going to create a text file. We can pick, I guess we're working with the person table, so let's use person. So what I'm going to do, I'm going to create a new text document, just called persons or something, persons.txt, okay? And what we're going to do, we're going to take all of the responses from our SQL query, and we'll go back to querying everything because we know there's like 19,972 people in our database. And what we're going to do is write every single person's name to this text file, okay? You can imagine we could be more selective if someone was asking us for a couple of email addresses. You obviously don't want to send them like a SQL query because not everyone is savvy enough to read that. You want something human readable, something that you can copy paste into an email, for example. Anything like that you would, or like automatically email the response of. That's how you would do this, right? Streams, okay? So yeah, there's a lot of purpose to this. Let's say we want to write the first name and last name of every single user in the database to this text file. So what we're going to do, so I'm going to say select star from AdventureWorks person.person. We can run that. Okay, guys, so once again, we have the same question. I need to get the first name and the last name this time. So we know last name is 6. Where's first name? Okay, yeah, 4, exactly, cool. So, okay, we're gonna be writing, so the first name and the last name with the space between, and we're getting reader.getValue. You guys will see this will be very easy to port across this code to just write it to a text file instead. So you guys see here, when I said console, remember we discussed it once before. Console is really just a really long text file, right? It is a stream. It's called the standard input output stream. Okay, the standard input output stream is console. So console is just a stream. So when we say console.writeLine, we are writing to the stream of console, like that's the backing store. Console is our backing store. And so actually writing to a text file is exactly the same. I'm going to say using system.io, okay, like so. And I'm going to, oh, that rhymed. So then I'm going to say, all right, we've got a stream writer. And usually they call these, okay, they're recommending some names. Cool, we can use writer. Usually you want to use an even shorter name, I suppose. And then we're just going to open up a new stream writer for the text file that we're writing to. Okay, so persons.txt in this case, I think it was called. Okay, something like that. Now, literally, instead of console, literally all I'm changing, once I've opened the stream writer to that text file, all I'm changing is I'm going to change console to writer. Okay, and that's it. That's all. So now it's just going to write to the text file instead, assuming I didn't make any sort of spelling errors or whatever. So I'm going to build that. It's building. It's built. I'm going to run it. Okay, you can see it no longer printed anything here. It no longer printed anything here. But if we go to our text file, persons.txt, it didn't print anything here either. That's fantastic. Love these live demonstrations. Okay, let's see what's going on quickly. Writer.writeLine. Wait, was I running the new one? I'm not sure, actually. Oh, was the name correct? Persons.txt, it is correct. Okay, maybe I should have. Yeah, it was very quick actually. So that's probably, oh, maybe we said where first name is Adam. Okay, hold on 1 second. Select star from AdventureWorks person.person, that's better. And reader.getValue 4, reader.getValue 6. We're writing to the file name while reader.read. That makes sense. Let me just make sure. Okay, hopefully it'll work this time. Oh, it was a little bit slower, but still not, I don't think. Okay, this time it did work. So the problem was that I didn't remove the where statements. Don't ask, why didn't it print out the Adams? Because I didn't change anything else. Why didn't it print out the surnames of the Adams? Let me just think quickly. There'll be some reason, but whatever. Okay, so there was something wrong with the code, but now you can see we've got 19,972 lines of code. Okay, 19,972. Okay, so it got every single name from the database. You can see this is a very, very, very long text file, and my computer is lagging terribly. Okay, it's fine now. But yeah, lots and lots of names. So that's working. Cool. Obviously, we will want to be more specific than that. Okay, before we finish today's lecture, I do want to show you, okay, so that was flat files. So that would be a difficult thing to demonstrate. But the other thing I want to show you is just these other ways to execute queries, just because you can be asked about it, and then we'll probably end there and finish next week, which I'm okay with. I didn't think it would take so long to, I guess we did have some technical difficulties, correct? So that probably is why. Anyway, so you've seen this command.execute reader just executes the entire query and gives it back to you, gives the response back to you into an SQL data reader. There's two other options. There's execute scalar, which returns just the first cell. Okay, so just the first cell. What do I mean by that? Instead of returning this entire thing, okay, instead of returning all 19,972 options, it'll literally just return this. It'll just return one, the thing in blue. It'll just return that. It's good to show the, yeah, in a way it is. It's good to, yeah, I agree. I do apologize though, but it is also the first time I'm giving this particular lecture as well. And there is a lot that can go wrong. That's why we put it in a try catch. So there you go. Cool. So we've got a 1 there. So that's all it would return if you ran execute scalar. Shows us that always, yeah, exactly. Okay, so when would that be useful? So I'm going to wrap the star inside a count. You see, I've wrapped the star inside a count. When I run this, if I execute that, ooh, we've got an error. That's fantastic. Why? That's very strange. Let me think. Counts expression returns int. Ah, okay, cool. Why didn't that run the first time? It's exactly the same. Okay, anyway, yeah, things don't always go right when coding. True. Okay, cool. So you can see what this returned. It just returned one cell, but you recognize that number, right? 19,972. By wrapping the star in counts, what it did, instead of returning the response, it returned the number of rows that would have been returned by the response. Okay, so this is when execute scalar is very useful because it is much faster than a normal query. It's optimized, okay? So what it does is it just returns that first cell, and it's faster than a normal query. So for example, if I wanted to run this instead, so I'm just gonna run this instead. So instead of select star from adventures works.person.person, we're just gonna say select count star. So this will return one cell. So I could say execute reader and save it in an SQL data reader, but you can see that's pretty slow, right? Like we have to create an object called SQL data reader. We have to go to the server, execute the entire command, return it as if it's a whole table instead of just an integer. So if you just say command dot execute scalar, so this will instead just return the first row and column. Okay, execute scalar. It'll just return the first row and column. So what we're going to say is var reader command.execute scalar. Okay, and then we should be able to just print out that number now, but I think by now you guys get the idea. So the point is that execute scalar will just return the first thing. You can see it returns an object because it doesn't know what it is, right? It doesn't know what's saved in the first cell. So you have to save it in like this var thing, which is a little bit slow. But it just means that C# is going to decide on the type, basically. And hopefully when we build that, it's just going to print out the ints, but it might give some trouble. but otherwise it's fine. Yeah, cool. So it just prints out the int, you see. So it just prints out 19,972. Okay, so that's much faster. So execute scalar, all it does is returns the first cell. Okay, so the first cell, not the first row, the first cell. Everything else is ignored. Okay, so if you said select star from AdventureWorks person.person.person or whatever, person.person, then and you ran execute scalar, it would literally just give you one. Okay, just one, just the first cell, because the first ID is one. The other option is execute non-query. So you can see that we've been using queries to, okay, we're going to go a little bit over time for this, but this will be interesting. Let's update the table. Let's update the table. So okay, I spoiled it. You know how we update a table. It's the update statement. So I'm going to say update adventureworks.person.person. Whose name are we going to change? Let's just change Alex to, let's change Adam to Eve. Okay, that makes sense. Let's do that. Assuming there's no Eves in the database already, that could break things. But anyway, so let's say update adventureworks.person.person, set first name equal to Eve, where first name equals Adam. Okay, I think that's a pretty fun query, Rip. I was just trying to think of a fun query on the fly. But anyway, okay, so when I run this, okay, there were 53 Adams in the database, and they're now Eves. And we could change it back pretty easily if we say set first name equal to Adam, where first name equals Eve, and hopefully it's still 53. Okay, still 50. There were no Eves in the database. Okay, so there we go. Now it's back to being Adam. And cool. So we've got this statement here. We're going to run this statement instead. Okay, we're going to run the statements instead. Okay, so update adventureworks.person.person, set first name equal to Eve, where first name is Adam. Okay, so this is going to update all of the Adams to Eves, and then we can do the reverse as well. But now what you'll notice, you see what this returns here. It just returns 53 rows affected. 53 rows affected. If I ran this now, because there are no more Eves in the database, you can see if I run this now, it says 0 rows affected. So you can see this is not a query. It's not returning a response from the database. It's just telling us the number of rows that our query affected. Okay, and that's what execute non-query is for. So you can say command.execute non-query, and this returns an integer telling you the number of rows that your query affected. Okay, that's all execute non-query does. You can see if I mouse over it, it says executes an SQL statements against the connection and returns the number of rows affected. Okay, so we're going to change all of the Adams back to Eve again, and then we'll see that it'll print out 53. Okay, so I'm going to say build solution, and you see it prints out 53. Okay, so and now if I ran it again, you can see it prints out 0. You aren't selected anything, so return the columns and rows. Yeah, exactly. There's no columns and rows to select, precisely. But if you said execute reader, it wouldn't be able to return the number of rows that were affected. But because we said execute non-query, what that allows us to do is when it's not a query, when you're not selecting things, when there's no response, it allows you to just count the number of rows that are affected. Okay. So those are the 3 ways that we have to execute SQL statements from C#. Okay, and next week I'll show you the last thing, which is the C# data set, which is how we work with huge amounts of data, like in machine learning or something, you would use data set, I guess. Although no one really does machine learning in C#, but hypothetically, that's what you would use it for when you're working with large amounts of data inside the computer's memory. So yeah, we'll cover that next week along with stored procedures. Sorry, I used 2 extra minutes. Apologies. But yeah, thank you guys. I guess this would not be our last content lecture. Next week will be. But yeah, I guess there's a lot to get through today.
So,
yeah, you do.
So have a good weekend. Thank you.
Yeah, you too. You too. Cheers. Yeah, thank you guys. Yeah, you do make games with C#. And I guess there you would be working with a lot of data. Yeah, thank you guys. Have a nice weekend as well. Thanks for coming. See you next week. Cheers.